Some sets can be very difficult to unlock or disqualify. In this Fraser's spiral diagram, we've established a set that makes you believe that all the lines spiral into the center. Even when we break the set, by tracing the concentric circles with the pointer and showing the dot gets no closer to the center, you'll still find it difficult to unlock your original set and convince yourself it isn't a spiral. Another powerful mental set relates to what we know and believe about rectangular shapes like windows. Here is Ames' trapezoidal window. As it moves, it appears to oscillate, and a wooden rod appears to pass right through the frame. In fact, the window isn't a rectangle at all, but a trapezoid, and it's revolving slowly about a central point. If a playing card is placed on one end of the window, you can see, if you keep your eye fixed on the card, that the window really does rotate. Take your eye away from the card, and your set of the oscillating window recurs. Seeing is a synthetic process, and sometimes highly erroneous. Let's see how the unknown importance of visual texture trapped the crew in polar conditions. Visual texture is vital for perception.
The tower here today are reporting the visibility as 40 miles, even though we know it is well in excess of 40 miles. This is because 40 miles is the maximum visibility ever used in aviation. Flight 901 also had a reported visibility of 40 miles in the McMurdo area, and yet they remained calm and unaware right up to impact that they were in fact observing in clear air a 13,000-foot mountain directly in their flight path. Visual texture is vital for perception. The islands, houses and trees and other objects in front of us inform us on color, shape, edge and other physical characteristics. These provide the information necessary to the eye to make judgment of relative size, distance and depth. Non-polar trained pilots normally work in an abundance of such visual texture and can confidently judge distance and depth to within meters. However, they would be unwittingly vulnerable in white surface conditions, particularly under an overcast sky.
The cloud base and the sea ice.
Right.
And that means that this distribution of light in this region is uniform. And if you've got a uniform distribution of light, you just don't see objects.
Right, so
To
you
see
lose
objects,
your shadows.
Yeah, to see objects, you've got to see edges.
Right.
And edges come from differences in brightness in the visual field.
So you've actually in this area then got a total saturation of light
That's
rays
right.
impinging from all directions.
That's right.
I get you. So a monocolour surface would just, contour would just totally
Right. The
disappear.
contour disappears.
Believe it or not, you are now looking at a heavily contoured white surface with a reflective sheet above modelling the overcasted Erebus. Because of the saturation of light rays being rebounded, all of the shadows have disappeared and with it the last vestige of visual texture. This is whiteout, caused by the albedo light reflected from a high layer of overcast cloud, with the sun at an angle of 38 degrees or less, and is the true whiteout situation as distinct from being in a blizzard or blown snow, which is the normally held misconception of whiteout, and the one which was incorrectly used to brief the crew of Flight 901. In the case of true whiteout, the eyes would inevitably misfunction without you being even vaguely aware of it, and they would fall to their natural focal length of 2 to 3 meters. This situation is known as the Gansfield effect. So even a huge mountain sitting in here would just suddenly disappear?
That's right.
Removing the effect of the overcast sky, the visual texture returns immediately, even though this is a heavily contoured monocolor white surface.
Presently, you're the only one flying in Antarctica, 11 kilos.
Let's see how the crew of this Flight 901 were trapped. They proceeded up the McMurdo Sound area towards a large layer of cloud over the Ross Island, Scott Base, McMurdo area. This cloud left most of the rest of the Ross Island shelf free, and all of the Victoria Range, Cape Bernacchi, Wilson's Piedmont, etc. in the clear. Collins would have been visually ranging on all of these fixes as he commenced his letdown towards McMurdo Sound. He knew his approach to McMurdo, and his clearance, in fact, allowed him to make a descent under visual flight rules. That is, clear of cloud, knowing that he would have to fly in under the lip of this cloud. Then run back in the safety of the clear air beneath the cloud for a visual approach to the McMurdo Sound area. However, because the waypoint was changed without their knowledge, we know that they were actually tracking visually up into Lewis Bay on a collision course with Mount Erebus. The green line represents the expected track into McMurdo Sound. The amber line represents the actual track into Lewis Bay. You will notice the angle shown onto the relative bearing or azimuth of the blue lines exactly match, and so do the angles on the red lines. The red line in McMurdo to Cape Royds closely matched the red line to Cape Tennyson in both angle and distance. The blue line to Cape Bernacchi matches the angle onto Cape Bird Cliffs, but you will notice this blue line is only approximately 1/3 as long. Therefore, visual ranging onto these cliffs was erroneous. But because the cliffs of Cape Bird are only approximately 1/3 as high as those of Cape Bernacchi, they would subtend exactly the same retinal angle and present an almost identical visual image to that expected by the crew. Non-polar trained crews operating in crystal clear air with no intermediate visual texture would inevitably be trapped by this unnotified phenomena of false visual ranging. All of these azimuth lines tie in with the voice recorder for the flight and clearly show that the crew and Mulgrew saw almost precisely what they expected to see in the reported cloud and flight conditions.